Welcome to cryptography session. Today I am going to give an example for a polyalphabetic cipher. Here poly means many. So polyalphabetic ciphers means we can able to get many ciphers from the given plain text. So multiple letters are used at a time for one encryption. If you go for a plain text, we can able to join two letters as a pair. So if you join two letters as a pair, then that pair is called as diagrams. If three letters are joined as one pair, that is called as trigram. So each diagram or trigram of plain text is taken as a single unit, and for that single unit only we perform encryption method for retrieving the cipher text values. If the pair contains two letters of plain text, two letters of ciphertext will be retrieved. If a pair of three letters of plain text is available, then we can able to retrieve three letters of ciphertext. So the number of plain text is same as number of ciphertext. But only condition for implementing polyalphabetic cipher is the length of key should be greater than 1. If you go for a monoalphabetic cipher, two techniques are available. One is CCS cipher and another one is affine cipher. On those two type of encryption algorithms, we were only using a key length as 1. That is, only one letter is treated as a key. But in a polyalphabetic cipher, we can able to use more than one length as a key. So a general name for this polyalphabetic cipher is a polyalphabetic substitution cipher. So all these techniques have this common representation. Instead of a single plain text, we can able to get many ciphertext. So based upon this, the first technique is a Playfair cipher technique. It is a best known multiple letter encryption mechanism in which two letters are treated as a pair. So those two letters of pair is called as a diagram. So in an encryption, if a diagram is taken for encryption, we can able to translate two letters of ciphertext. The step 1 of Playfair cipher is the construction of 5 cross 5 key matrix. So 5 cross 5 contains 25 values. Here a plain text is taken from the set of alphabet values. Total alphabet values are 26. So at least two letters should be specified in a single column in a key matrix table. So we can able to store individual 26 letters in a key matrix. So how can we form the key matrix? Means if the keyword is given, we should take individual letter from the keyword. If the letter is already available, we can ignore it. So we should frame or we should construct the key matrix value in a row wise order, and then there is no duplicate letters in a key matrix. So if a letter is occurred two times, we should only use one time in a key matrix table. Here the example of keyword is monarchy. So monarchy. So there is no duplicate of these letters. So first we should fill the first 5 letters of keyword, and the remaining 3 letters of keyword is stored at the second row. After finishing the fill up of the given keyword, then we should fill the missing letters of the given keyword. So already A is available, so we should fill the letter B. C is already in a keyword, so we fill it as D. Then E is not available in a keyword, so we should fill E. Then consecutively F, G, I and J are mixed here. And then K, L, M is already available. M, N, O are already available, so we fill the remaining letters like this. So it is the first step of Playfair cipher algorithm. Second step is we should split the plain text as a two-letter pair. For example, if a plain text is given as balloon, so if two-letter pair means BALLOON. So these are all four pairs. The last pair contains only one letter. Third step, we should verify either any pair contains same letter or not. So if you take the first pair, the letters are different. If we take the second pair, it contains the same letter. In that situation, we should insert an additional letter X in between that pair. Again, it will be splitted into two-letter pair. So then now the pairs contains BA, L and new inserted letter X. Then the next L is combined with third pair, then ON. And we should check that whether all pair contains two letters in it. If the last pair contains only one letter, then we should fill that pair with an additional letter X at the end. This is the third step. At fourth step, we should take each letter pair and that letter should be referred in a key matrix table. So there may be the possibility of three situations of the occurrence of those two letters. For example, I am taking the first two letters pair BA. Suppose if the letters are occurred at same column, then we should write its beneath letter as a ciphertext. For example, the first pair value is BA. It is occurred at fourth column. So I am writing the ciphertext as the beneath value of B is I, the beneath value of A is B. Otherwise, we can write it as, instead of I, you can able to write it as J. So the answer of the first one is either IB or JB. Then the next two letter is LX. So L and X. So those letters are occurred at different row and different column. On that situation, we should go to the first letter row order. So the first letter is L. So you should refer to row order, then that will be crossed with X. So the intercrossed value is S. Then you go to column order of first letter. So L column order, X row order is U. So the answer for LX is SU. The third letter is LO. It is also in different row and column. So the first letter word is L. So you should go to row order. So the intersection value is P. Then you go to column order. The intersection value is M. So the answer for LO is PM. And then the next letter is ON. It occurred at same row. At that situation, we should write its right side value. So oth right side value is N. Nth right side value is A. So this is the ciphertext answer. If you want to retrieve a plain text from the given ciphertext, again you should refer the same matrix. But if the letters are occurred at, I am writing the notes for decryption. So if the letters are occurred at the same row, you should write its left side letter. If the letters are occurred at same column, you should write its topmost value. That means its immediate top side value. For example, my ciphertext value is LB. So sorry, IB. So I is available here, B is available here. So same column, you should write top letter value. So I topmost value is B, B the topmost value is A. So the answer is BA. Then if you check SU, S and U are available. The same encryption mechanism should be followed. So S is the first letter. So you should go to row order. So S and U row order intersection is L, and S column U row intersection value is LX. So we can able to get the second plaintext value. If it is LO, so LO is, the answer is PM. So PM, it is also occurred at a different row column. So you go to the first letter row order. So the answer is LO. Then NA, it occurred at same row. At that situation, if you want to do decryption, you should write its left side value. So both nth left side value is O and A left side value is N. So in this way, we can able to retrieve the decryption mechanism by using the same keyword matrix. One point that should considered, which means that if in an encryption, if same row letters are available, we should write its right side value. For example, I hold the answer as HD. So you refer the value HD, plain text in a table, H and D's are available. H's right side value can be written as Y. And if you refer D is the last value, there is no right side value, immediate right side value is available. At that situation, you should write the first letter of same row. So D is the last letter of second row. So I should go to the first letter of second row. So the answer is YC. The same situation is for column. We should write only the beneath letter. For example, my plain text value is FV. I want to write cipher text. So F beneath value is P. V is the last value at the second column. There is no beneath value. At that situation, you go to the first letter of second column, same column. So the answer is PO. In this way, we can able to do the decryption also. So if you want to go to the left side value for decryption, if there is no immediate left side is there, you should write the same row last value as given plain text. So this is the way Playfair cipher works. It is another example. The keyword is monarchy. So I already give an instruction for filling the values in a key matrix table. So I am taking value as happy Onam. You just ignore the blank space, extra blank space within this keyword. So and I split it as two letter or a diagram as a pair. So HA, PP, YA, NA, M. So totally 5 different pairs are there. And the second pair contains same letter. So we should insert an extra letter X. Now the splitting of pairs are HA, PX, PY, ON, AM. After splitting the value, all the pairs contains different letters and all the pairs contains 2 letters. Then at the third situation, we should refer every plain text pair in a key matrix table, and we should refer the 3 type of cases, and we should write the ciphertext. So HA, different row. So H row value is B, H column value is O. So the answer is BO. For PX, different row. So Pth row value S, column value V. So SV. PY, it is also a different column. So P row value Q, P column value H. So the answer is QH. ON, same row. So right side value is NA. AM, so A right side value is R, M right side value is O. So this is the ciphertext value. And if you do written process, that means reverse process. Decryption means you refer BO, so row value H, column value A, so HA. SV, SV, so row value P, column value X, so PX. QH, so qth row value P, column value Y. So in this way, we can able to retrieve plain text. So after retrieving plain text, we just combine all the values, and if any X's occurred at the 2 consecutive same values, then we should check that whether this X is necessary or not for giving the meaning of the program. So I retrieved Happy Onam with X as an intermediate value. So just check here, it is an extra X. So its left side and right side values are same value. So if I hide this X, then this plain text will give the meaningful one. At that situation, you can remove that extra X from the plain text. So this is the overview concept of a Playfair cipher and its implementation. And the main advantage of Playfair cipher is for a single pair. Suppose if I taking example as HA, depending upon the key value, the matrix, that means the answer of ciphertext will be differed. So if I am writing HA, the answer is varied. If I am writing it as AH, the answer of ciphertext will be varied. So there are 26 letters are available, and in a Playfair we are using a diagram. So there are the possibility of 26 cross 26. That means 676 diagrams are possible for the same plus plain text. So the identification of individual diagrams are more difficult to deduct, and it is not easy to break the code by using a Playfair cipher. So the relative frequencies of individual letters, that answer will be greater than that of the given diagram. So for this reason only, Playfair cipher will take long time for decrypting that code without using key or an next algorithm. So it is one of the best encryption method which comes under a polyalphabetic substitution cipher. The next concept, Wigner cipher concept and its problem will be discussed in next class. Thank you.